Today we're dealing with area of trap. Clean sheet of paper that you've taken out, and after you fold it in half, what I need you to do is you've got a bunch of parallel lines on it. So thank you for letting me loan me yours there. You're going to draw a decent sized trapezoid. Now it'll help for you to remember what the properties of a trapezoid are. So go ahead and tell your neighbor how you know something is a trapezoid.
Two parallel lines. You wrote it down.
It's a trapezoid's a quadrilateral, and it has to have one pair of parallel sides. It can only have one pair. If it has two pairs, then we call it a
Rectangle.
not necessarily rectangle. Parallelogram, okay? But if it has one set of parallel sides, so that is parallel to that. So one set of parallel sides. Once again, this means parallel here, okay? One set of parallel sides has one set of parallel sides, and it's a trapezoid. All right. So what I need you to do on your folded sheet of paper is using your parallel lines that you have. Can I borrow yours again, Kira? Okay, using the parallel lines you have, sketch in a trapezoid. So drawing your lines and making a trapezoid. Use your parallel lines to your advantage on there. Okay, on one side, sketch in the trapezoid, and after you've sketched in and drawn your trapezoid, then you're going to take your scissors and you're going to keep the paper folded and cut out your trapezoid. So once you're done cutting, how many trapezoids will you have?
2.
You'll have 2. Okay, go ahead and do that now. Okay, how many of you have your twin trapezoids? Yeah. All right. And we recycle our scraps. Woohoo!
If you have the formula, I'll put it down. Of course. What was it?
At least the one that I have down.
You right there, Grace?
Just falling out of the chair.
All right. Okay, wrap up discussion, please.
Too bad we don't have a falling out of the chair part because he'd be amazing at it.
Okay, everyone's eyes and ears back up here.
That's what I just said.
Okay, you have your 2 trapezoids. Everyone's focused back up here. Maddie, Maggie. Okay, you have your 2 trapezoids. You made your parallelogram. We have our height. Okay? Area of a parallelogram is base times height. What's the area of a trapezoid using our parallelograms there? You got one person? What do you think?
This is what I think.
Yeah.
This is going to be completely wrong. But 2 base times height divided by 2.
2 base times height divided by 2. Well, that would just mean base times height.
No, that would mean base times half height.
Oh, so you're saying 2b. So you're actually saying 2b
H over 2.
times h over 2. It's like that.
Yeah.
Okay, it's not quite right.
But is it close?
It's kind of close, yeah. Yeah.
Well, if you're already putting them together, like you said, it would just be base times height.
Okay,
I
so
thought it was base times height divided by 2.
that's pretty darn close also. Let's look at this. So let's say, what is my base? Well, if I call this a base, and actually we're going to have to designate that like base 1. And then I call this one my base.
2.
And we're going to have to designate that one a base 2 because they're 2 different bases, right? Everyone see that? We got base 1 and base 2. Okay, and then we have a height. Logan, do you have a question? You think you got it? Okay, using that information, see if you can come up with your formula now. Talk with your neighbor. You get about 30 seconds.
Haley had it written down the whole time. Good job, Haley. Wait, is this B? Is it B1 times B2?
No,
B1 plus B2.
times H.
There. I was like, why wouldn't you just...
All right, Logan, what do you think? Okay, everyone's done talking. Logan's got our attention here. Okay, hold on. No side talking. Go for it.
B1 plus B2 times the height divided by 2.
Okay, so we have B1 plus B2. So that's the length of the base. So if we use the formula for area of a parallelogram, the base length is B1 plus B2. And then you're multiplying, is it the same height? The same height. And then why are you cutting it in half? Yeah, there's 2 of them. So we only want one of them. So we take that one out, which means we cut our area in half. So we divide it by 2. That is the area of a trapezoid. Now the other way we write that is 1/2 base 1 plus base 2 all times h, or 1/2 h plus base 1 base 2. So usually you'd see it like that. All those formulas are the same there. Okay?
Oh, no.
All right. Any questions on it? So we use the area of a trapezoid or a parallelogram to come up with the area of a triangle, which we did last week. We just cut remember, we cut a or a parallelogram in half, you get a triangle. Or if you double a triangle, you get a parallelogram. Well, with a trapezoid, if you take 2 parallelograms and put them next to each other, you get, or excuse me, 2 trapezoids next to each other, you get a parallelogram. Cut it in half, you now have your trapezoid, and we have our formula. Okay. Any questions on it? I want you guys to take a look at number 1 on your assignment.
Which side?
Example side. Find the area of each trapezoid. In fact, number 1 and 2, I want you to work with your partner there. Come up with those areas, please.
I charged. I will revive.
That's big.
16. Wait, 16. What's 16 times
96.
Okay, does it matter which one's B1 and which one's B2? No. Ooh, you can add it in any order. Okay, half of 6 is 3. So we get 3 and 10 plus 6 is 16. 3 16ths is also known as 48 square centimeters. Okay, remember your height is your right angle height. It's not a slant height. Now we don't see that on this, but it has to be your right angle. It goes from base to base at a right angle. Okay, notice you don't distribute the half into each thing. It only comes into one. Okay, tell your neighbor what you got for number 2.
What's 56 Yeah.
It is 1,568.
Divide by 2?
784, which is what I thought.
Okay. Yeah.
Okay, so 34 and 22. It gives me 14 times 56, which is
784
784
inches
square inches. Thank you. Okay. How many got it? All right. Any questions? Okay. Why don't you try number 4 then? Number 4 says find the area of each trapezoid given the height, base 1 and base 2. Just want you to try number 4 only. Don't need to worry about 5.
Not rads. They are lame. They should be lamicals.
Lamical?
Yeah.
Wow. All right. That's not very nice. Poor radicals. Changing radicals' names to lamicals. I don't know. Boy. All right. Well, at least we don't have any lamicals in this problem. No radicals either. Okay, 1/2 of 7 times 9. Now you can multiply in any order. I'm going to multiply 7 and 9 first to get 63. So 1/2 of 63 happens to be 30.
1.5. You said 31.5.
Oh, so 35.
All right,
Yeah.
31.5
Oh,
square feet.
That's what you told me. So
All right, well done.
And then you wrote down 35.
Okay, any questions yet?
It's Monday.
can't blame me anytime.
That too small? You guys gotta tell me. Don't squint so much. You know, if you're like, hey, I can't see, tell me. All right.
Usually it's because I'm wearing the wrong prescription glasses though.
Me too.
Yeah, I need to get new prescription glasses.
Me too.
I have glasses. I just never.
All right, well, let's make it totally radical.
The lamicals.
Okay?
Yeah, lamicals.
Kara likes to call them lamicals, but I think they're radical. Okay? So, number 10. Find the area of trapezoids using special right triangles. That's why they can't be called lamicals. We're dealing with radicals. Okay? Should you round or leave in simplest form? Simplest radical form. What's it say in your directions?
Simplest.
Good. Number 10 says simplest radical form. So, first thing you need to do, if I'm solving this problem, okay, I have area equals 1/2 base 1, or 1/2 height times base 1 plus base 2. First thing you should always do is make sure you know these things. So far, it's been pretty easy. Okay? All right. Work with your neighbors. See if you can find those things, please. Okay, ladies and gentlemen, what is height?
3 square root 3.
Wow, someone got the height. They don't show us it, right? Secret agents, take your earbuds out. What's your base 1?
11.
Base 1, base 2. All right, 11. 8. Our height, yeah.
Okay, well, no. So if you made the right triangle, yeah, like that.
Yeah.
If you did that, then you'd have like a rectangle, and so you just find however like much is. Okay, I don't know how to explain this, but like on the top it's 8, so you'd have to make the bottom 8 too to make it a rectangle, so it'd be 3. The base of the triangle would be 3.
Okay, so if I'm following your thinking, you're saying that this piece right here is 8,
Yeah.
Yeah.
correct?
Correct.
And which means this piece right here is going to be 3.
Because it all equals 11.
True. Everyone agree with that?
Yeah.
Yeah.
Okay. Very good. So now how does that help me, though, to find height? Go for it.
Since it's like a special right triangle, you have like that. The 3 is like the x, and so the dotted line for the height that would be 3 square root 3.
Good. So this is a special right triangle. This is a 30, 60, 90. Okay, we know this is a 90. So this is 3. So remember the the pieces here. This is 3. This is 6, which we really don't care about, right, in this problem. But that's our 2x. This is our x root 3. or 3 root 3. So our height is 3 root 3. Now we have all the pieces we need. Now how many of you were able to find that 3 root 3? Good. Okay. That's kind of our goal, right? Is to apply these things that we're learning into new situations. So using that information, 1/2 height, 3 root 3. Now I'm going to use substitution. I'm going to put parentheses. Base 1 is 11. Base 2 is 8. Okay. Parentheses don't mean as much in there, but that shows that I plugged something in. Okay. So I get 1/2 of 3 root 3 times 11 plus 8, or
19.
19. Now that, they're saying leave this in simplest radical form. Holy cow. So really what I have here is 1/2 times 3 times root 3 times 19. 19, not 13. It's crazy. I could be saying something and write something completely different. 19. Okay? Yes?
What do you want to use 3 times 3 times 19?
Well, I would want to multiply all these things that are outside of the radical together. So what is 1/2 times 3 times 19? 28.5 root 3s. A lot of times we write that like 28.5. You could put that in fraction form, right? Okay, some of you are like, how do you do that? Well, 28.5 is 28 and 1/2. You could also think of, like, if I move that over, you'd be multiplying it by 10. But I'm going to leave it like this. I'm going to call it okay right there. Okay, I'm going to be fine with you leaving that decimal out there for right now. What is, oh yeah, the units, man. Square centimeters. Good call. Okay. Any questions on it? Can we multiply it by 3, the root 3 here? No, we need to leave it in radical form. Okay, I want you guys to try number 11. All right, hopefully everyone dropped that altitude. Base 2, I'm going to call 12. Base 1, this piece right here, just like Logan said earlier, that part's 12. Right? It's a rectangle. This part then has to be what? That's 10. Good.
As Haley would say, 12.
So this is then also 10, right? In special right triangle, 45, 45, 90. That's x, that's x, that's x root 2. Okay? That's 10. And then we got 22 here.
Wait, what? Oh.
So this is 10, 12, 2, 2.
Oh, so it's not.
All right. Now in this one, it's a little easier. Half of 10 is 5 times 12 and 22 is 34. 10 34s is 340. So 5 34s is half of 340, or 170.
I'm just good.
I was just testing you. Square inches. Good. You passed the test. Well done. All right. Think we got it?
Yeah?
Okay. Our assignment.
Mick.
Yes, Logan.
Okay, one more. The example side for number 12. Like, So would it be 0.5 root 3, or how would you do that? You just want us to leave it in point, like,
Yeah.
5?
1/2 root 3, or root 3 over 2 for your height, you mean?
Yeah.
Yeah, so if you're looking at this one and you're going, I know that this part is a half, that makes this 1/2 root 3, or root 3 over 2 for your height. Yes. Okay, your assignment is both sides, but you can skip that one and that one. If you do them, you can get extra credit. That's on the example side, so skip numbers 9 and number 6. Okay, if you already did them, you get extra credit. Okay, and then on the mixed side, skip number 16. Okay? Yeah, extra credit for that. All right, other than that, you got to do the rest. You can do it, though. You guys love this stuff. Dun 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 dun.
Yeah, I love lamicals.
I'm loving it. Yeah.